So in the last 10 problem solving walkthrough, we went over strategically guessing the answer. So we solved this problem right here and got an answer of 73. We're going to take a look at another math counts problem. This one is, from what I've heard, is very old. One of the first math counts problems there. Not sure the exact year of it, but it's very old math counts problem, but good strategies in this problem. So let's get started. Find the value of digit A in the 5-digit number 12A3B if the 5-digit number 12A3B is divisible by both 4 and 9 and A is not equal to B. Okay. So basically 12A3B is a 3-digit number, and A and B are digits. So when someone says 12A3B, in this problem, we're not multiplying anything. This is just a number. So the variables here are just digits. So this means that A and B, they can't be equal, but A is equal to any integer from 0 to 9, and B is equal to any integer from 0 to 9 as well. But, well, of course, they can't be the same, so, I mean, you can't have like 4 and 4 or something like that. But they can be any from 0 to 9. But it's dependent. Like if A is 1, B is now restricted from 0, 2, 3, 4, 5, 6, 7, 8, and 9. So that's basically what we're dealing with here. So divisible by both 4 and 9. So our strategy here is the sum of every single digit must be every single digit must be equal to a number divisible by 3. Because divisible by 3 should be divisible by 9, most likely. Or we can just, the sum of digits needs to be divisible by 9, so it's going to be divisible by 9. So we're going to choose divisible by 3, so basically, essentially you want 12 plus A plus 3 plus B is equal to a number divisible by 3. So essentially something like this. But we're not going to use this equation at all. I'm just going to keep it there so you know what we're doing. Notice that a number is divisible by 4 if the last 2 digits of that number are divisible by 4. So like 24 is divisible by 4, obviously. In this case, 3b is divisible by 4, and it should result in an integer value. Alright, so 3b needs to be divisible by 4. Now let's test all possible cases for b. So 3b needs to be divisible by 4. Let's test out cases. If b is 0, we have 30. 30 is not divisible by 4. If b is 1, we have 31, which is not divisible by 4. If b is 2, we have 32, which is divisible by 4. So b equals 2 is a possible case. Now, if b is 3, it's 33, not divisible by 4. 34, not divisible by 4. 35, not divisible by 4. 36, it is divisible by 4. So we have another case, b equals 6. We have 37, no. 38, 39, 40 is not a case. So 39, 38, 37 are not cases. So we only have b equals 2 and b equals 6. So our original digit is 12A3b. And I'm going to plug in b equals 2 first. And now we are going to check. We narrowed it down. We used some range. We got b equals 2 and b equals 6. And now we have 12A32. And first off, let's sum all the digits here, right? Let's sum every single digit here. Since 1232 should be a number that is obviously divisible by 3, right? So let's just get started. Let's sum every single digit first. Alright, let's just sum all the digits. So 1 plus 2 is 3. 3 plus 2 is 6. 6 plus 2 is 8. So we know 8 plus A needs to be something divisible by 3. Now we know 9 is divisible by 3, and if we plug in a 1 in the A, 8 plus 1 equals 9, which is divisible by 3. So we have a possible test case Possible case of A equals 1. That's one possible test case. Now let's plug in B equals 6. 12A3, 2, or not 12, 1, 2, we have, what was the original? So we go back to 1, 2, A3B. A3B. B equals 6, we plug it in. 1 plus 2 is 3, right? 3 plus 3 is 6. 6 plus 6 is 12. Well, 12 plus A needs to be something divisible by 3. Now, 12 is divisible by 3, so if we do A equals 0, we'll get a number that's divisible by 3. Now, before we move on any further, let's actually test out the 1, 2, A, 3, this number right here. So let's plug in A equals 1, and now we have a completely built number. Let's test this out first, because I don't think this is the one, because 12 is already divisible by 3. So, and I feel like if we increase it by a number, that'll make it something we don't want it to be. Like, we can increase 12 by 0, but if A is equal to 0, I want you to see the result. 1 plus 2 plus 0 is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 2 is 8, that's not divisible by 3, so A equals 0 is not even an option. So let's just cross all of this out, since that's not a possible case. And we cannot honestly even remove the B equals 6, since that's not a possible case. So 1, 2, 3, 1, 2, 1, 3, 2. 1 plus 2 is 3. 3 plus 1 is 4. 4 plus 3 is 7. 7 plus 2 is 9. 9 is divisible by 9. So this works for 9. Let's test 4. Now we already know if the last two digits are divisible by 4, the entire number is divisible by 4. 32 divided by 4 is 8. This means that 1, 2, 1, 3, 2 is the number we're seeking. Now we want the value of the digit A. So 1, 2, A, that's going to be this digit right here, so the answer is 1. Now, approaching this problem, what you should do is, well, you should do everything I did, but you should first test, like, you should do everything I did, but I did the B equals 6 test case just to explain why we have B equals 6, but I would just first, as a strategy to get your answer faster, I would test the B equals 2 and then decide what to do later, because if a number is working, I wouldn't bother testing any other cases, because if it satisfies every single thing, you have your number. Like in this case, we have 12,132. So it works out. So that means the value of B is going to be 2. So, and that makes sense since 1 plus 2 is 3, and 3 is divisible by 3, and that makes sense. Now, what you could have done, which also works, is you can sum A plus B, and then you can say 3, and then you can just kind of guess and check 1 plus 2. So, and that's also a possible case, but yeah, that's how another example of strategically guessing out the answer. Hopefully this video is helpful, and yeah.